We take a look at just a quick review of what we've been working on for the last 2 weeks. Here's Mr. Elmhorst with the help video for the homework assignment, proportions, tables, graphs. Oh my. So what is a ratio? We did the definition before. A ratio is a comparison. And what is special about the ratio is that they are alike items or same type of thing. So fruits, you can have strawberries and bananas, but they're both fruits. They are alike. And then a rate is going to be a comparison also. But what is different about the rate? Rates are comparing different things. Miles, hours, time, distance, things that are not the same. And one more definition, unit rates are, yet again, it is a rate, but it's a special type of rate where it's being compared to a unit of what? One. Dollars per hour. Meters per second. Per meaning one. So the last part is proportions. When we set up a proportion, we have a ratio or a fraction is made out of two of them. Two equivalent ratios. So down below, what would we do to this first ratio to make it equivalent to a number out of 5? 12 out of 15 would be equal to what out of 5?
Divide by 3.
So we're going to do a factor, divide both of these by 3. So in the middle, in order to keep these equivalent, we're going to divide the top and the bottom of the ratio by the same factor. Okay, moving on to the next one. Use the given information to help you compare. We're going to compare and make them equivalent by using the same factor. What do we multiply 6 by to get 30? 5. So 5 out of 6 would be equal to what?
25.
25 out of 30. Using the given information, 16 divided by
4.
4. Then we do the same thing to the top and the bottom. 24 divided by 4 would give us an equivalent ratio. Now we can get fancy and just go one step further just because and divide both of these by 2. Times 7 times 7. Our multiplication tables are going to help us out with ratios. So 3 times 7 is 21. 9 times 7 is going to give us 63. All right, so take a few minutes, finish up the ones down below. Simplify this ratio by a factor of 5. 15 divided by 5 is going to give us
3.
3/8. Next one, dividing by a factor of 3, that's going to simplify to 6 out of 10. Dividing by 4, dividing by 4, that's going to be 12 out of 16. And the last one here, times 9 times 9, 63. Okay, looking at the next table, this you're going to have to do a little advanced thinking. And the direct relationship, 18 does not have a direct multiple that works left or right. So in order to fill out this ratio table, we might have to look at some other comparisons. Does 24 have a factor that works with 12? Sure does. Divide by 2. So we're going to come over here and do the same thing down below. So 24 out of 18 is equal to 12 over. That's going to give us 9. So I'm going to clear that out. Now we have 12 over 9. Does 9 help us out with 4.5?
Yeah.
It sure does. Divide by 2. Divide by 2. So 9 divided by 2 is 4.5. 12 divided by 2 is 6. Okay, so we were stuck with 18 just for a little bit there. I'm going to clear it out just so we can see. Now that we have 6 over 4.5, we go back to 18. Does 6 have a factor that works with 18? Times 3. So we're going to do 4.5, use the same factor, multiply by 3, and that'll help you complete the table. So I believe we're going to end up with a decimal on that. We're going to have 13.5. Okay, moving over to the next one. How do you go from 40.4 to 80.8? Times 2. So we use that factor down below and multiply by 2. Okay, check your answers for the table on the right. So the last one, when you end up with a 10.1, to keep the ratio equivalent, 10.1 is being compared to 128. All right, down below, be careful reading the graph. So this one is your y. Traditionally in 6th grade, we had x variable on top, y variable on bottom. This one is the other way around. So this is actually your total weight here. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. So it's starting with your output variables, and then you go down here for your inputs. 1, 2, 3, 4. The weight of the items is 1, 2, 3, 4, 5. So it looks like this one is doing the output first. Looks like 2, 4, 6, 8. So go ahead, fill that table out. And then down below, a shower uses 12 gallons of water in 3 minutes. How much water does it use in 1 minute? How'd you get that? 12 divided by 3 is 4 gallons per minute. So you go down below, 3 minutes is 12. And it looks like we have a multiplying factor of times 4 times 4 times 4. You may not be able to graph all of these, but time in minutes, when that is 2, the water is 8. 2, 8, 3, 12, 3, 12, and then 5, 20. So it looks like we have a linear relationship where it's just being multiplied. And the y output is equal to whatever the time is multiplied by 4.